Exercise 7L, number 1. All right, what I'm trying to do here is to explain how to use the TI-84 plus CE to do a binomial distribution CDF. The PDF is pretty straightforward and very similar to the Inspire, but the CDF is different. Let's start here. Now with number 1, it says given X is distributed binomially, where n is 6, that's the number of trials, and the probability is 0.29. Find the probabilities, A, that the probability of X equals 4. Now that's just a PDF, and that's the same on both calculators. So if you have the Inspire, you would just enter it as 6 for trials, 0.29 for P, the probability, and X equals 4. And that's a PDF. And on both calculators, you should get that answer. B is a little bit different. Now, on B, if you've got the Inspire, if you're used to the Inspire, you would choose binomial distribution CDF because this includes 0, 1, 2, 3, and 4. And on the Inspire, you would do CDF and you would put in from 0 to 4. But that's not the case with the 84 plus CE. On the 84 plus CE, you just put 4 for CDF. And that 4 by default includes 0, 1, 2, 3, and 4. And you'll get that answer. C is very interesting because on the Inspire, well, the first thing you need to recognize is that says less than 4. So effectively, it's X is greater than or equal to 1 and less than or equal to 3. So keep that in mind. When you use the Inspire, you will choose CDF, binomial distribution CDF, and you'll put in your trials, which is 6, you'll put in your probability P, which is 0.29, and then you'll put in the range from 1 to 3. Remember, that would be 3 because it's less than 4. You're including basically 1, 2, and 3. And the Inspire does that quite smoothly. And the 84 plus CE, that's a bit different. You're going to have to find the CDF for 3, and then what's excluded is the 0, because it doesn't include 0. It includes only 1, 2, and 3. So when on the 84 plus CE, when you put a 3 here, that includes 0, 1, 2, and 3. And that answer would be that. But that's not the answer to this one, because you have to exclude 0. And the way to do that is minus the probability of X equals 0. Now, you can choose CDF or PDF to do this. If you choose, I choose either, and then when you put it in, you put in 6, 0.29, and 0. That's X equals 0. That's why you can use PDF. But you can also use CDF because it would also just be 0. And then you get an answer of 0.128, and then you minus this from that, and you get 0.809 to 3 significant figures. Now what I've done on the next slide is to have a look at what the input is for the 84 plus CE. Okay, let's have a look at what it looks like on the 84 plus CE. I don't actually have this calculator, but I borrowed it from a student and I took some photos of the screen. Now we go back to C, and this one we said was effectively X is greater than or equal to 1 and less than or equal to 3, okay, because it's less than 4, so less than or equal to 3. These are the steps that we just looked at, and that's how you get to the answer of 0.809. On the calculator, you choose binomial CDF, and you put in a 3. Okay, you put in the X value of 3, as we've done here, and then you get the result of 0.937, which we have here. Okay, and that 3 would mean that would include 0. So we have to exclude 0 because the range is from 1 to 3. Okay, effectively that's 3, right? So to do that, we put in a 0. So now what I've done is, I've done it again. I'd use CDF. You could use PDF for this step. And I've put in a 0 because it's only one X, right? X equals 0. So I put in a 0 now. And the result was 0.128. And that's how I got that number there. And then I subtracted the 0.128 from the 0.937. And I got 0.809. And that's shown there. Let's have a look at D. D is probability that X is greater than or equal to 2. And we're focusing on the 84 plus CE, but I still would like to mention that the Inspire would be quite simple. You just choose binomial, CDF, and you would choose the range from 2 to 6, since 6 is the limit. So the Inspire, no trouble at all. But the 84 Plus CE, you need to do this step first and then minus that step. Now this step is basically you choose CDF on the 84 Plus CE and put in a 6. When you put in a 6 in CDF, it's 0, 1, 2, 3, 4, 5, 6. It's all of it, and that's 1, actually. Right? And that makes sense that it's 1. And then minus what we're excluding here, and we're excluding 0 and 1. We don't need 0 and 1 because it's only 2, 3, 4, 5, and 6. So to exclude 0 and 1, you choose CDF again, must be CDF, not PDF, and you put in a 1, because the 1, when you put in a 1 for CDF on the 84 Plus CE, you're basically calculating 0 and 1. And that's what we need to take away from this to get that range there from 2 to 6. So you put in the 1, and then we minus basically we're minusing the 0 and 1 from the 0 to 6, which would end up with 2 to 6. And that's what we did here. And we said that when you put a 6 in there, it's going to be 1. You put the 1 in there. This, what we're minusing is the 0 and 1, and we get 0.442, and we get 0.5579638090005, or 0.558 to 3 significant figures. For E, it's a conditional one, and the way you read that is x, the probability of x is less than or equal to 4, given that x is greater than or equal to 2. Remember, when we do conditional, we always focus on the denominator first, and that is going to be x is greater than or equal to 2, and we have that here. So find the denominator for this conditional probability. Use answer to 1D, because 1D is x is greater than or equal to 2, and that's what we have here. So 1D, we got this answer here, 0.557. Use it all, don't use the rounded one, use all. And then you've got that. And then once we've found the denominator, we're going to find the numerator. Now the numerator is quite interesting because it says x is less than or equal to 4, but given that x is greater than or equal to 2, so basically we're only interested in 2, 3, and 4. So we need to find 2, 3, and 4. And the way that you can find 2, 3, and 4 on the 84 Plus CE is to find the probability of x is less than 4 or equal to 4, and that includes 0, 1, 2, 3, and 4, but we have to minus 0 and 1 because we're only interested in the 2, 3, 4 part. So we do that, we put the 4 in here, and that answer is 0, 1, 2, 3, and 4, but we've got to take away the 0 and the 1 because we're only interested from 2. And so we put a 1 in there, and that will remove that, and then we get this answer here to 3 significant figures. Okay, so now we've got the numerator, the denominator and the numerator, and then we put them over each other like this. Okay, and then we get this answer, 0.983 to 3 significant figures. Let's have a look at F. F is use your answers to determine whether x is less than or equal to 4 and x is greater than or equal to 2 are independent events. You've seen this before with conditionals. They're basically asking us, is this event independent of that event? For independent events, the probability of x is less than or equal to 4 must equal the probability that x is less than or equal to 4 given that x is greater than or equal to 2. And since answer 1b that we saw previously does not equal answer 1e, the events are dependent or not independent. Okay, and then we get to question G, which is the easiest ones, G and H. Find the expected value. Now, x distributed binomially, where n is 6, the number of trials, and the probability is 0.29. Well, from the formula, expected value here, it's just 6. It's just basically n times p, which is 6 times 0.29, which is 1.74 for G. Find the variance of x. Well, there's a formula for that too. And given that x is distributed binomially, and we've got n is 6 and p is 0.29, the variance, which you will find in the formula book, is 6 times 0.29, which is p, and sometimes you'll see this represented as q. Here it's represented as 1 minus p. It's binomial, so 1 minus p is equal to q. And we get 6 times 0.29 times 0.71, and we get 1.2354. or 1.24 to three significant figures.